So in this lab, we're going to go through a cycle of copper reactions. So you can see the cycle that I've drawn for you here. Everything is, of course, in your lab book, okay, that you have. I'm going to explain a few things here that are going on. I know it's a very busy slide. This would have been the flow chart if you had been in the lab. But I'm going to do this whole cycle here for you, and you have to take observations as you go. So let me first explain what's going on. Okay, so you have the procedure in the lab book, so you can look at that as you're watching this video. But let me show you here also what's going on. So technically we're supposed to weigh copper, but even when we are going to do the lab in the lab for real, we don't weigh the copper, so that part is out. So which means what we're going to do is just take a little bit of copper in a test tube, and then we'll add a little bit of nitric acid to it. So then we'll watch the changes that happen. Going from adding nitric acid to copper will give us copper nitrate. Then we're going to add sodium hydroxide. That will give us copper hydroxide. Then we will heat it using the Bunsen burner a little bit, and that will give us copper oxide. Then we'll add sodium sulfuric acid, not sodium, but sulfuric acid, and that will give us copper sulfate. And then we'll take it back to copper. So copper is going through so much. Now, why can copper do all of this? Copper can do all of this because it's a transition metal. So when you have transition metals, they're very reactive. I shouldn't say they're all very reactive, but this one does react very well with different chemicals. And the lovely thing about copper is it gives so many different colors. Okay, as you're going through this, you will see that the color changes are going on. There's also gas formation, precipitation. So we talked about in class, at least in my lecture, you must have talked about in your lecture about how to observe for a chemical reaction. So how do you observe for a chemical reaction? You look for precipitate. You look for gas formation, which is called effervescence. You look for heat changes. You look for light formation, which is chemiluminescence, and you look for color changes. So 5 things, and these things are already written for you in your book. Okay, so they're all here. I think somewhere they should be here, but in any case, if they're not, I just told you, okay, what you're looking for. So this is a little bit of an intro of what you're doing. This is going to be the experiment. Now I have a lot of marks because I would have told you what to do and what not to do while we are here. But in any case, I'm going to do the whole entire thing here for you. And what I want from you is your observations, because this is what we call a qualitative lab. Qualitative meaning the quality of things, okay? It's not quantitative. Quantitative would be weights or volume, which is not what we're doing in this lab. So this is going to be qualitative. So what you're going to do in this one, okay? So you'll have the pre-lab and all that good stuff that you're going to do. But then for page 83, you're not going to do page 83 at all, because this is the weights part, okay? So we're not doing any of the weights. You're going to go to the next page, which has all the observations in it, okay? So let me explain to you what you need for observations here. When you write your observations, because this is a qual lab, you need to write color changes. Not just that it turned blue, but from what to what. So was it colorless before? Remember, clear is not a color, okay? Clear is clarity of things. If something is like water, clear and colorless, so it's a colorless, that's the color. So does it go from colorless to blue, or does it go from red to blue? So that's how you should write the color change. If you see a precipitate, then you should write that a precipitate was observed. Not only that, what color was the precipitate? How thick was it? Okay, was it thick? Don't write chunky, we'll leave that for soups. So just write whether it was thick or fine precipitate, if you can tell from the picture. If you see any gas formation, what was the color of the gas? How much was it? Was it very intense, or was it just light? If you see any bubbles or effervescence, as we call it. Now, when we say effervescence, that really is literally bubbles forming in a solution. But because we have gas evolution, without the bubble formation, that is also called effervescence. So you can write either way as you wish to, okay? So, but if there's any gas formation, you should also write how much it was, what color it was, things like that. So today for this lab, your entire grade is going to be how you write your observations, okay? There's one other thing I would like you to do, and I think you can do this, is when you go through all these reactions, as you're looking at that, I would like you to classify them as acid-base, redox, or precipitation reactions. Those are the three chemical reactions we have learned so far in lecture. So you should be able to look at all these reactions and classify them in one or the other way, okay? So here are the things you're doing. You're only doing this part, so when you look at the video, look for changes, the chemical changes that are going on, color, gas, precipitate, whatever. Heat, you can't tell. I'll tell you, okay, if there's any heat changes because I can feel the test tube. And then you're also going to write what kind of reaction it is, okay? That will give you full points if you write all of that in there. And that's your lab, so make sure you observe carefully. I'm going to leave this on here just in case we get to see this again, although probably not, because I'm going to go ahead and do the reactions now. So in any case, that's that for now, and let's start the reactions. So here I'm taking a little piece of copper, and you can see it's a wire kind of thing, and we get metals in different shapes and sizes. We get them in rods and pieces, and you've used magnesium strip already. This is a wire, okay? So I'm going to take this copper wire and just take a little bit of it. Remember, we're not weighing anything, so I'm just going to make it a little bit of a little bead over here in my hand and put it in a test tube. And I have a feeling I should take a little bit more because then you can see some nice reactions. Otherwise, it might be a little hard for you. So I'm just going to take a little bit more, make it into a bead. There. I don't need gloves for this, so I know you're probably thinking she's not safe. I am safe, I promise you that. Okay, so we have little beads over here now. So I'm going to do the first reaction, which is adding nitric acid, and nitric acid is concentrated nitric acid. So I'm going to be very careful with this one because nitric acid is very strong and it's very corrosive, as we've learned. And to hold a stopper for any kind of acid or base, this is how you do it, okay? So hold it like this, and you'll be dealing with acids later on also, okay? So this is a good technique to follow. And then you use a pipette. You can use your same hand, and if you're not comfortable, then you can use the other hand, okay, as you wish. I'm going to use the other hand right now because my test tube is over here, so that way you can also clearly see what's going on. So I'm going to take a little bit off the nitric acid, and I'm supposed to add enough to just react all the copper in there, okay? So I'm going to add this drop by drop, and you can see what happens. And you can see I'm doing this in the hood because I guess you can tell from the reaction what's going on. So I don't want to smell all that gas that's coming out. And we just add one more drop. And I'll stop now. The main thing over here that I want to make sure is that I have no copper left behind. Okay, so I don't think I have any copper left behind. That was the first step, okay, that we did. Okay, now I'm going to have to move out of the hood. Okay, so I added the nitric acid that was in the hood. Now I'm out here. So it says that I should wait a little bit, but the waiting is only for the copper to react. So it's all reacted right now. So I'm here right now in step number 3, and step number 3 tells me to add 10 drops of water. So I'm going to squirt just a little bit of distilled water in there. And trust me, I will not ruin your experiment. Okay, so you'll be fine with that. And so here, let me lift this up so you can see what's going on. Okay, so that's adding a little bit of water. Nice pretty colors, okay? So I want you to write the colors nicely. Don't give me aqua, okay? I have no idea what aqua is. So give me blue, light blue, green, light green, dark green, something, whatever it is, or red if you're seeing red, but don't give me aqua or something, okay? Because I don't know what that is. Okay, so now we're going to go on to part B, which says add sodium hydroxide. Now technically it says that you need an ice bath, but you don't really need an ice bath, okay? We'll be fine without the ice bath. Trust me on this. Again, I hope you trust me by now, okay? But in any case, so trust me, and we'll add the sodium hydroxide. Now in this case, I'm going to keep adding until we see the change and until we stop seeing the change, okay? So that's the whole point for this part here. So in the reaction scheme, when you add the sodium hydroxide, you should get copper hydroxide, which in the equation also it says it's a solid, so that's what we're looking for. This one I'll go step by step, okay? So make sure you observe carefully what's going on. And I'm not shaking it too much. I will eventually. Okay. There. I'm not going to tell you what to look for. I can't add too much of it, because if I add too much, whatever changes I have, they'll be gone. Okay, so at this point, this is what I have, and I'm going to shake it a little bit. Don't feel dizzy, but that's what we have. Okay, so this was part B, okay, of adding sodium hydroxide. Now I have to go to the centrifuge, but to go to the centrifuge, what I have to do is, let me see if I have to add any water to this. I don't think so. Turns cloudy, blah, blah, blah. And then, yeah, so here we go, turn the page, and using a beaker to collect the waste. Okay, so here, add to centrifuge. At this point, yeah. For this, I need to take an equal amount of water, because in a centrifuge, you need to balance with the amount of water. I'm just taking distilled because it's close to me, but otherwise you don't really need distilled water. You just need to make sure that it's just about the right volume. I'm really sorry that you are not going to be able to use the centrifuge. I think this is the only lab where you use a centrifuge, so you're going to see me use it. Here is the amount, so all equal to go. And we're going to centrifuge this for about a couple of minutes, I think. Let me see, 30 seconds to 1 minute. Okay, so let's walk over here to the centrifuge. So you can see the video also that I have for the centrifuge, but otherwise the main thing about a centrifuge is to balance. And here I'm going to keep this on the opposite side, and now there's nothing exciting except to just turn it on for about 1 minute, and you can hear it. We'll just let it go for a minute. So waiting. 28. Okay. I'm looking at the computer time. What the centrifuge does is it separates the solids from the liquids, so that's what we want to do. I think I gave the game away, right? So there's a solid in there. Okay, so now we've had the centrifuge done, and you can see what it looks like. Now, because I didn't use the ice bath, and I'm not doing this twice, because technically you're supposed to add water to this and do it twice, you can see that there is something at the bottom over here, okay? And I'm supposed to decant the top part. So decanting means just leaving the solid behind and getting the liquid out, okay? So I'm going to go ahead and pour that out in a beaker. And there's that. So this is what I'm left behind with, okay? So note the color, okay? See how much I have. And I know we didn't weigh out the copper, and I actually can't weigh out anything right now either, so it doesn't matter. But this is what we have, and this is the waste, okay? The waste is just the waste. There's nothing much happening there. So now this is going to be step C, where I'm going to go ahead and turn on the Bunsen burner and heat the test tube a little bit. So now this is ready for the heating part of it, which is part number C, where we're going from copper hydroxide to copper oxide. So I have to turn on the gas for this, so let's do that. Now in this case, we are not going to be using the cone, okay, the very heavy heating, because in this case you need just a light heat. So we need the yellow flame, not the blue flame, okay? So right here is the yellow flame, and here comes my test tube. This is always the exciting part, because the solid that's at the bottom here, that can actually jump out and whatnot, so I have to be careful. And I want you to watch carefully as to what's happening in here. And I'm not going to point it towards myself. And I hope you saw what happened. Right. And that's it. Okay. That was the very quick reaction that happened right in front of your eyes as we were heating it. And I'm done with that. So I'm going to turn off the Bunsen burner now. So that was step number C1, okay, where we have to heat it. And it says where the solid ejects, but you can see my technique. So good, all right. Nothing ejected out of the test tube. And now I'm going to add sulfuric acid to this, 10 drops of sulfuric acid. So let's do it this way, and here is my sulfuric acid. In this lab, it is kind of really important to make sure that you read the labels carefully, okay? So I'm gonna go ahead and I think the test tube is still warm, okay? So adding the sulfuric acid now. And I can see that I still have some on the sides of the test tube, so, oh! Got it. It's safe. It's a save. That's why I was trying to get it out of the test tube holder. Okay, all right. It's a good save. Okay. So this is the sulfuric acid. And now the last step. Okay, so in the last step here, it says that dilute the solution with the DI water. So I'm not going to dilute it because I've done this reaction before and it doesn't quite work very well, okay, if we add water. So I would have told you that if you were in the lab, but even otherwise, now that we're doing it here, I'm just going to go ahead and add magnesium to this now. So this is the magnesium strip you've used before, and we're going to use this again. So I'm just going to take a small piece of this, and see how easy it was to break that. Okay, so I'm going to take half of this and I'm going to throw it in there and we'll see what happens. And this is actually the last step also. So this is going from copper sulfate now because the sulfuric acid turned it into copper sulfate going to copper. So we are actually at the last step. Okay, this is the cycle complete. So I want you to look at this carefully as to what happens when we add the magnesium. Look at the reaction, what is supposed to happen, and then see what's happening here. Look at any other changes going on in there. For example, any solid formation, any color changes. I know, that's a pretty intense reaction going on, right? And you're probably thinking, oh my God, I missed all of that. I'm so sorry. Okay, I'm going to shake this now. Don't get dizzy. Okay, now I'm going to add water to this, okay? So you can see clearly as to what's going on. So I didn't add water before. I'm going to add it now. By the way, the test tube is like super hot right now. But I don't want to use the test tube holder because I know what happened before. Okay. So I don't know if you can see this or not, but hopefully you can see the little piece of magnesium still there, okay, and that's still bubbling. And look at the color. Look at any solid formation that's going on. This is the last step, as I said. So here's what I'm going to do. While you observe this reaction, I'm going to have to go ahead and get a spatula and I'm going to remove the magnesium, okay, because then you can see a little bit better, okay? So I will be right back. So I'm going to try and remove the magnesium from here. This is always a fun thing to do because it doesn't want to come out. There, I got it, I think. Yeah. I got it. Okay, so I don't have to take it out. I'm just going to leave it out of the reaction itself because what I would like you to see here, if you can, okay, and let me put something white behind so you can see the color, okay, because I would like you to see the color of the copper in there because this is the copper that we got back, okay? So think about the copper that we used before and then look at this copper that we have over here. Okay, so see if you can recognize the color and write the color of this, okay, in there. And this is it, okay? If we were doing a quantitative thing, we would have centrifuge this so we get the copper at the bottom, and then remove the water, dry the test tube. So it would have taken another half an hour to finish all of this. But this is it. This is as far as the whole cycle of copper reactions that we did. So I hope you enjoyed that little demo that I did, and write your observations carefully and in detail as much as possible. The nice thing is you can rewind anything and see anything except for my accident, but you can see everything in there. Okay, all right, let me know if you have any questions. Thanks.